To take over?
Awesome.
Welcome, Mike.
Sweet, thank you very much. Welcome to Putting the Fun in Functional Android Development. So some of you guys might be wondering, what is this talk? What are we doing here? What does it mean to write functional Android code? And does that even actually work? So this talk is really a dive into me answering the questions that I was running into. Can you write functional code in a user-facing app? When you have to deal with all these side effects and issues with updating databases, talking to the users, can you even write functional code? And in the end, I want you guys to decide whether you think that this was a successful thing to do within Android. I'll give you my answer, but I'm going to lay out everything that I ran into, and you guys can decide for yourselves. But before we go into that, I think it's important to know my background and where I'm coming from. So I'm 26 years old. I'm a mobile developer at A6 Digital, which was formerly Runkeeper. I went to Northeastern University and graduated a CS degree. I did a minor in math, but while I was there, I took classes in object-oriented programming, and then I took a class called Programming Languages, which dove into fundamentals of how programming languages were created. So it talked about functional elements such as currying, lambda calculus, et cetera, et cetera. The thing is, by the time that I had taken this class, I had already done all of my co-op sessions, which are essentially 6-month internships, and I've done a lot of imperative coding at that point. Also, my classes were a lot of imperative, so when I was in that class, I was like, this is all theoretical, right? I mean, this is just like how these programming languages were created. This isn't really used in real life. Math is worthless, right? So how did I go from that to this talk? So when I graduated, I started full-time work at Runkeeper. And about 2 years ago, we introduced Kotlin into our Runkeeper Android code. But I was essentially just writing Java, except with a new language. So I actually took this as an example from our code, which I was embarrassed to find. We are iterating through a list of workouts. Within that workouts, we're searching for a workout with a specific UID. We're removing that workout from the list that we are iterating through, putting back an updated workout, and then returning. So the good thing is we're breaking out of this iteration, but we're also mutating the list that we're iterating through, which is kind of like trying to change the tire of a car while you're driving it. It's not something that you ever want to do. Things got a little better as I understood the functions like map, filter, reduce a bit better, but these are really just tools. A lot of my code was still very imperative. So I started doing a little more server work, which is more functionally written. It is written in Java, but it's structured much more functionally. And one of my coworkers that I was working with was teaching me the basics of functional programming. And he led me to this article that was written in 2001, and the author's, his name was like just Oleg. That's all I could find on him. It's just one simple name. But the article talks about this subclassing, subtyping problem within object-oriented programming. And to illustrate this problem, let's imagine you have a class called a bag. It's essentially just an array of integers. You can just throw integers into this bag, put as many as you want in. But we want to create a more specific version of this. So we create a class called set. A set is a subtype of a bag, but it can only have one instance of any integer, right? Pretty straightforward. What we can do is we can add this method called add1twice that takes in a bag and adds the number 1 to it twice. This is possible. What we can also do is we can create a new set, and we can pass this to the add1twice method. This is something that the compiler will allow you to do, but it doesn't make any sense, right? This illustrates the main problem with a lot of imperative code is that, and not imperative code specifically, but subtyping and subclassing, is that this completely breaks the contract of the add1twice method. And so what can happen is you can run into issues where a method gets passed in a subtype, and this creates some side effect that you weren't expecting because it was given a subclass that it wasn't expecting. So can functional problems solve this? Well, the short answer is yes. You can solve a lot of these more object-oriented and imperative problems by having all of your functions adhere to a specific set of principles and guidelines in order to stay pure. And I'll explain exactly what pure means later, but essentially what it is your functions don't create any side effects that you don't expect. Whatever your function is supposed to do is the only thing that it does. And again, I'll go into that more later. But what that means is that you can prove more about your code just by knowing the signature and the contract. So let's take a step back. What exactly is functional programming? Well, functional programming is just a paradigm that is comprised of a series of mathematical functions. So all these functions must be in the form of f of x equals y. No exceptions. This is just a math formula, right? But this is really important for a programming app because it means that for all conditions of your app or all conditions of your system, an input x to whatever function must always produce the same y. And functional programming has a lot of these confusing terminology. You've got like monads, monoids, closures, higher order functions, currying. I'm not going to get into all this. I'm just going to dive into a couple of key concepts that I think are really important, especially for developing Android apps. The first one are that functions are mathematical functions. So we're going to come back to this f of x equals y. This always is the case. And if we take a mathematical function, we can take something like y equals 2x plus 10. If x equals 2, that means that y is always going to equal 14. 2 times 2 is 4, plus 10, 14. This means that for no condition of the world is y ever anything different if x is 2. Doesn't matter if it's raining out, doesn't matter if it's Tuesday, y is always going to be 14 when x is 2. And your programming functions have to act the same way within your system. So going back to purity, a pure function is defined as the output is solely determined by the inputs of the function, which is what I was just explaining. And then no observable side effects can occur as a result of this function, right? Because no things that you don't expect to happen can happen. And by adhering to these principles, we can actually catch a lot of runtime exceptions that can get caught by the compiler. So the next thing is mutability. And the rule of mutability is don't change anything. It's obvious, right? It's the name of the word. But what this means is that you cannot reassign variables. You have to always create new ones. And the benefit to this is that it makes threading and concurrency much easier. Because remember, you no longer have to worry about the state of your app. So if two threads are vying for different variables, they no longer have to worry about this anymore because they're running pure functions which don't care about the state of your app. I spilled a bunch of water myself. That was great. So concurrency within imperative programming kind of assumes that you have this higher knowledge of the entire system. It assumes that you know every place that a variable is going to get changed. You know when you run this function, all the trickle effects that are going to happen. And we're humans. We can't possibly know, especially in some of these bigger systems and older apps, we can't possibly know every single small little side effect that's going to happen. And this is where functional programming can really benefit. Last one is functions as a first-class citizen. So this basically just means that functions can be stored as constants and passed around to other functions. But this is really powerful because we can start proving things about our code without actually knowing exactly what those functions do. We just need to know the contract of those functions. So we can take map for an example. And map is a really powerful tool that combines both immutability and functions as a first-class citizen. So we can pass in a function to map across a list, and we can create a new list. We know a couple things about this new list without knowing anything about that function. We know, one, the list is the same size as the previous list. And we know, two, if the function takes in a type T and converts it into type R, we now have a list of type R. We don't need to know what was going on in that map function, but we can guarantee that for sure. As far as object-oriented programming goes, we can use design patterns to help alleviate some of these problems. And these design patterns are really meant to help get people on the same page But the thing about these is that there's so many that how do you know which one to use when? And especially if you're dealing with an older code base, I'm sure you've seen a lot of different iterations of design patterns. So once again, I hopped into the Runkeeper code base and I decided to do some digging. So I found that we use a factory pattern somewhere. Pretty normal. We have the builder pattern. We use some singletons. We use MVP at Runkeeper, so this is an MVP class, a base MVP class. So we got some subtyping as well. And to make it crazy, we have an abstract subtyping MVP factory, which is again wild at this point. So you can see how a new programmer or someone who hasn't looked at code, looked at a specific part of the code for a while, might be very confused on which pattern to use. So then, why introduce functional programming into Android? Well, if we can avoid the mutation of state, if we can avoid worrying about race conditions, this is going to make our lives so much easier, for obvious reasons. What we can do is we can make our lives easier with unit testing as well, because we don't need to worry about setting up the entire app or an entire feature in order to unit test a specific function or a specific portion of the code. And then as well as that, if you're debugging a part or you have a new employee and you give them an assignment, they can jump in and look at a function. And again, without knowing the entire code base, they can reason about what's going on in that function. That being said, effects are necessary. We are dealing with user input and output. We are dealing with saving information to a database, writing calls to servers, writing analytics. These are all effects. So we have to do it. We can't avoid it. But can we take those effects and we push them to the most outer areas of our code so that everything in the middle, all of our business logic, is all functional. And the only times that we have to create an effect are on the outer limits of the world, we can say. So that leads me to my first experiment. Can I take a simple Runkeeper feature and turn it functional? First off, is it possible, let alone is it worth it? Let's dive in. Runkeeper has this feature called live tracking. Live tracking is essentially a feature where you can text a link to your family, friends, loved ones, and they can watch your run as you go on it. So this might be if you want to run a race, if you're running late at night or an area that you're not familiar with, and you have safety concerns, you can text a friend, text your wife or husband, and have them just keep track of your safety. So this is one of the screens. This is basically just your selecting contacts, there we go, to send this link to. It's a very simple screen. All we're doing is we're just grabbing a list of your contacts, both from your phone and then from the server if you have any backed up, displaying them to the user. User can either select up to 5 and save them, or they can back out if they don't feel like doing this anymore. So, like I mentioned earlier, we follow the MVP pattern. All of our business logic is in the presenter. So taking a look at our presenter, I immediately find that we have this variable called contacts, which is a list of live tracking contacts. This is already a red flag. This is exactly what we said was against functional programming. Also looking at the methods, all of them break purity. They're all void methods because this is MVP pattern. They don't actually do anything. They kind of just make calls, and then from there they update the view. So you can take a look at this very bottom section where we set the contacts, and then we call view.display contacts with the list that we just received. And so this is what our MVP pattern really does. We grab some data, and then we don't return anything with it, but we tell the view what to do. So we tell it to display these lists of contacts, or we tell it to display this text, something along these lines. Our save contacts method is pretty similar. This is broken out, so if this looks confusing, I apologize. I want to get the important parts on, but we essentially have two portions of this. One portion, which is in the bottom left, is saving the contacts to your local database on the phone, and the portion to the right is saving those up to our server. The difference in these, and the reason why they're broken out, is because we don't necessarily care about the right portion. We don't care about the result of saving it to the server. That's really used as a backup. Saving it to your phone is the important part. We can't actually proceed with the way that it was written without saving it to your phone first. So if we want to rewrite this, we should first take a look at the contacts. And we use RxJava at Runkeeper. So what we can do is we can load up the way that we grab your contacts. So we need to wait before loading them because we don't know if a user has actually granted us permission to load up their contacts. So we can't just make these calls or we're going to crash. So what we can do is we can load up the way that we grab these. So instead of contacts being a billable list of live tracking contacts, we can now wrap it in an observable, and we can load up that observable. And then once the UI is ready, all it has to do is just subscribe to this observable, and we can get the updates. Search becomes pretty simple too, because now it can take a stream of a list of contacts, and it can take a name, and it just filters through that. Once again, now we have an output. And lastly, save now gets broken into two portions. We have the local storage and we have the server storage. Again, the reason for breaking them out is because we can't proceed without local storage and we don't necessarily care about server storage. So that's why they actually have two different results as well. Locally, all we need is that Boolean. So we can subscribe to this and when it produces a Boolean, we can check whether it's true or not, display an error, or proceed. And saving for the contacts, we can again subscribe to this, but it's now completable. So once it completes, we don't really care. If it fails, we can log that, keep track of it. So there's one little caveat. Within our recycler view adapter, which is the way that we have to display this list of contacts using the recycler view, we do change the property of isSelected within the live tracking contact. This is considered an effect. Within this app, this is kind of the outermost extremities, and for this experiment, I kind of chalk this up to this is an acceptable place to make an effect. In reality, if I were to go back and rewrite this completely, I probably would have changed the way that we were doing this, but because this really is dealing with the user interaction, this is a place that an effect can be made. But the benefit to this is that we just change the presenter without having to really affect too much in your app. So doing a lot of rewrites within a company is often pretty difficult to convince your managers to do because they want the latest and greatest, they want the newest stuff. And going back on tech debt is not really a priority always. So being able to explain that you don't need to go through this big rewrite, you don't need to change everything that's making this app, and then you can just create rewrite a small portion. This demonstrates that. So, experiment complete. That was kind of simple. All we were doing is just loading a list and then displaying it. What about if we have a dynamic list? That's when things get a little tricky. Introducing Arya's list app. So let's say Arya Stark is in the modern age, and she's just tired of repeating the same names over and over again. She wants to keep track of this somehow. What we can do is we can build a very simple app that she inputs the names, keeps track of, so that she can delete them later. But this app is very simple. All it does is just simple CRUD operations. We're going to create new people, which in this case we're just going to represent by a string, and we're going to remove them later. So my first pass at this, I decided to try and not use Rx, again because we use Rx within Runkeeper, but I wanted to see if it was possible to do it without it. So we had this view adapter that takes in a mutable list of people, and it takes in a delete function. This is very straightforward. Get item count is just going to return the size of the list, and onBind view holder is just going to grab the person from that list, display or update the view based on the information, and when the delete button is clicked, we're going to run the delete function with that position. Pretty straightforward, right? Now, when the submit button is clicked, we have to do something kind of funky. First, we grab the adapter from the recycler. Then we grab the list from that adapter. We concatenate this new person onto that list because we don't want to mutate that list. We want to create a whole new one. But then we have to create this new view adapter and set that on the recycler view. And this is really weird. This is pretty bad because every time that the list gets updated, we're going to create this new adapter and add it to the recycler view. Which means that if Ari is creating hundreds of names or deleting hundreds of names and it's constantly changing, we're going to keep replacing this adapter. And that completely defeats the purpose of the adapter in the first place. You're supposed to set it and then just update it as need be. So we don't want to do this. And you can look at the delete function as well. It's pretty similar. We grab the adapter, update the list, update the adapter. So I came to these questions. How can we add and remove people from a locally stored list without mutating this list at all? We can create a new adapter, but like we said, that defeats the purpose. I came across this idea where maybe I can pass in a function to add and remove, but that didn't really lead anywhere. And I kept getting stuck on this getItem count callback. And getItem count is a callback of the recycler view adapter that gets called every time an adapter is created, or not created, but an adapter is set on a recycler view, and every time notify data did change gets called. So it gets called pretty often, and it needs to read this information from somewhere. And in my eyes, there was only two ways that it could read this information. It could either read it from an immutable list, but that means that we need to create a new adapter every time, or it could read it from a mutable list, but then we have to change the list. And again, that's going against what we're trying to do right now. So I started doing some research, started reading around, and I came across this talk by Jake Wharton, who was introducing RX binding. And RX binding is a library based on RxJava that essentially streamlines user events into observables. So maybe what we can do is we can stream user events into an observable, convert that into a user event object, do some business logic on that object because now we have it in our own terms, and then return that result. And the UI will know what to do with the result. So maybe this is the way that we can solve it. We're going to have to define some events first. So the first event that we know is going to happen is Ari is going to create a new person. We know that that person, or that event is either going to be a submit person, which is going to have a name associated with it, or it's going to be an empty. It's not going to do anything. Based on that event, we're going to have some sort of result. Again, it's either going to be a success or a failure. And the success is going to return a list of people. Then on the deletion side, we're going to have a remove result. And that's either going to be successful or failed. So how are these used? We can use the clicks extension method on all UI views, which comes with RX binding, to streamline our click event from the submit button into one of these new submit person objects, or submit event objects. So we can do this submit button.clicks, which streamlines click events into an observable of unit, which isn't anything. And we can map that into a submit person event. So we grab the name from the edit text. If it exists, then we send along a submit person event, and if it doesn't, then we submit along a blank person event. Again, pretty straightforward. We pass that along to this process click event, which I'll get to in a second, but we know that we're going to get back a person result. And again, that's either going to be a new person success or a fail. So if it's a success, we can run it through Kotlin's when method. If it's a success, we want to update the adapter, clear out the edit text, and hide the keyboard. On the other hand, if it's a failure, right now we're just going to show a toast because that was the best way that I could come up with error failures in this short talk. But as far as the process click event goes, this is a very straightforward transformer. All it does is just, it takes in a new person event and it gives out a result. And again, we're working with our data types now. We're no longer working with these side effects that are happening. We're coming in with an event and we're returning a person. So in this case, if it is a submit person event, we're going to pass it to the service to add the person. Otherwise, we're just going to stream an empty result. What about the adapter? The adapter is only going to take into context now. The context is, again, just for error reporting, but our get item count is now querying our service to get the amount of people. Bind view holder, on the other hand, is also querying the service to get the person and then updating. We're doing a really similar thing that we did with the submitting, the submit button, with the delete button, where we're streamlining deletion clicks. And then from there, we're going to pass the person into the delete person method on the service object. And again, we know that we're going to get some result back from it. Whatever that result is, if it's success, we notify the adapter to update. Otherwise, populate some error message. So what about this service that we're talking about? The service kind of just turns into this API that we have that all of our business logic can talk to. And the benefit here is that it becomes a single source of truth. And then the portions that we have to do some sort of effects, like adding a person or removing a person, we turn into observables. So we kind of streamline these effects so that they're not run until they're absolutely needed to. And that when they are run, we at least have this object that we can return. The other thing is that we now have these more functional methods that we can run tests on. So the get people count and get person at position, these are our public APIs that the adapter was asking for information from. But these just kind of pass our people array over to this more functionally defined method called get person at position function and get people count function, which are pure functional functions, which is exactly what we want. So if we want to update this, if Arya is tired of saying the exhaustingly long names that are Game of Thrones characters, and she wants to, let's say, sort them so that the longest names are at the top, we can add a sort method to our activity. A sort button, not a sort method. We can do a similar thing with Rx binding, where we can subscribe to click events on this sort button. Here we're going to pass in a comparator, which just compares the length of characters' names, and we're going to apply it to the service. Once again, if it's successful, we're going to update the adapter. If it's not successful, in this case, we're just not going to do anything. The adapter is going to have this apply sort method, which takes in a comparator and sets a variable within the service. And when we update the adapter, what we're now doing is we now have to update this get person at position function, which again, now we can reason about. Now we can look at this get person at position, which takes in a position, takes in a list of names, and it takes in a comparator. And without really knowing anything about the app, we know exactly what this function is doing. And we can test it easily with different lists of names, different comparators, and all sorts of things. So like I said, with using more functional practices, you can now locally reason about any portion of your app without knowing the entire state. And this is a really powerful thing. So coming back around, what did I learn about this? First, I learned that functional programming is really hard. It's really, really challenging, especially I've been in the industry for full-time 3.5, a little over years, and I've only really done imperative programming. And to get yourself to not think in imperative ways and to think in pure functions, where the input is always defined by the output, vice versa. The output is always defined by the input, is really challenging. But it's nice because now we have these, this control over effects and results. And we don't always have to just mutate things and worry. We now have control that we can push these effects all the way to the outer boundaries. We can replicate these in unit tests by creating our own events, creating our own results. We can pass them along to UI tests so we can mimic different situations that a user might be in. The main thing that I want you guys to get from this talk, though, is try and use immutability as much as possible. It's going to save you a ton of hassle. If you are constantly worrying about other threads tearing functions out from under you, this is going to be a very nice way of simplifying your business logic and clearing up a lot of code that can get hairy very quickly. So coming back to the question, is this worth using in an Android app? I say yes. This takes a bit of a learning curve. I am still very early on in this, but I think that it is highly worth it and that you can simplify your app so that anyone can come in at any stage in their development and take a feature and know exactly what that feature is doing, how it's functioning, what's going on, and what they would need to change to update it. That's all I got for you. Thank you guys.
Do we have any questions? Questions? We have a question.
Mike, thanks for the talk. Where do you think you would draw the line between kind of some of the extra effort it makes to make something functional versus the gains you get from it? So like for that adapter, for example, if you just mutated the list, then you'd be able to get rid of a whole bunch of code.
Yeah.
So where do you think the line is for like, at what point are you going too far into the functional realm and the trade-offs not becoming good?
Yeah, that's a great question. I think the more simple the application, usually the trade-offs aren't beneficial at all. If you're doing more asynchronous code, if you're doing more threading, that's where you're really going to see the benefits. So it's tough to draw a hard line in the sand, but what I would say is if you're working on something very simple, very straightforward, you're probably not going to get any benefits from it, or you're probably going to get minimal benefits from it, but the more complicated the system is where you're really going to see your benefits.
Questions? Okay, then mellow it out.
It's all that
I
sugar.
think that's what we got. We got one more session.